Hey, it's great to be here. Are you guys ready for a great show? Let's get started. So I was talking to my friend Tiffany, great gal, and I asked her, who's hotter, Marilyn Monroe or Angelina Jolie? But then she said, I'm not really into girls.
This show sucks.
Ramon, don't you got a cab test tomorrow?
Yeah, but I don't know anything.
Well, I got this friend, George, who can help you.
There's actually a 6.
Whatever, Dad.
Making my way downtown, walking fast, faces passing, I'm going now. Hey, someone's calling! Hey, George Cosenza! Who am I speaking to?
SINEfeld. Hey George, can you come over and work on calculus with my son?
Sure thing, boss. You know, I'm the best at calculus.
No, that's news to me.
Wait, you have a son now?
Nope, some woman just shoved him onto me. Said he was my son and I didn't believe her. Then she just up and left and stuck him with me. Can you believe that?
Huh. By the way, you know I can calculate my displacement while I'm driving? I calculated that my displacement was 9.9 miles, and how did I do that? Well, I have the equation for velocity, which is in miles per minute, and it's 2.2 t. And then I put it into an integral from 0 to 3, and 0 is the beginning, and 3 is after 3 minutes. After I found the integral, I found that it was 1.1 t squared on the interval of from 0 to 3. And from that you get 9.9 miles. And let me tell you, my average velocity was insane. I did 9.9 divided by 3, and that gave me 3.3 miles per minute. You know how fast that is? That's like about 180 miles an hour.
You really are the best at calculus. Wait, hold up. You're not driving that fast actually, are you? Okay. This guy.
SINEfeld! Hey, how's it going, buddy? Glad to be here. SINEfeld, how have you been doing, buddy?
George, would you like some water in one of our conical cups?
I would love some water. I could drink a whole lake right now if I had to. By the way, you know, I'm able to find the rate of change at which the height of the water is increasing. Can you do that? Can you?
No.
So SINEfeld, at what rate is water coming out of this faucet?
The water is filling up at a rate of 138 centimeters cubed a second. Oh, and the radius is 8 centimeters, and the height is 16 centimeters.
Okay, I think I can solve this. The rate of change of the volume is 138 centimeters cubed per second, the radius is 8 centimeters, and the height of the cone is 16 centimeters. Therefore, you can say that h equals 2r, and dHET is equal to 2 dr dt. We know that the volume of a cone is 1/3 pi r squared times h. We know that h equals 2r, so we can substitute that in, and we get v equals 1/3 pi times 2r cubed. And then we find the derivative of this. We get dv dt equals 2 pi r squared dr dt. And we have the value for dv dt, which is 138, and we have the value for r, which is 8. And then all we have to do is solve for dr dt. And then we get 0.343 centimeters per second. We know that 2 dr dt equals dh dt, and that gives us 0.686 centimeters per second.
George, you're genius!
SINEfeld, I know that. I'm George. Cosines it.
Dad, do I have to study for my test?
Well, of course you do, Ramon. Son. And this is my friend George. She's gonna help you.
What's up, bro?
Fine. Can you just help me already?
I'll leave you guys to it then. George, make sure he doesn't get distracted while he's studying for his test.
Sure thing, sure thing. Alright, come on, let's do some math. Let's go. Start with the laugh tracks already. Are you serious?
Alright, Uncle George. I need help with this area under the curve problem.
Hey, dude. Speaking of curves, did you see that Victoria's Secret fashion show yesterday? It was the bomb. And by the way, you know that model, Adriana Lima? She has some...
Dude, quit it, man. Quit it.
Okay, you know what? Fine. But I have an equation that models that Adriana Lima's curves.
What am I supposed to do with that?
You gotta find the area under the curve? Duh.
The period is 4 pi because inside the sine function, it's x divided by 2. Therefore, 2 pi divided by 1/2 is equal to 4 pi. So we would then take the antiderivative of this function, which is -8 cosine of x divided by 2 from the interval of 0 to 2 pi, and we would get 16 units squared.
Good job, kid, modeling that supermodel's curves, but I know that I would have done it way better.
Dude, can you help me study for my exam and not talk about girls? Although, there is this girl in my class that I need to make a heart for.
Ooh, who's this girl?
Forget about it. It's nothing that important.
Dude, you know what you could do? You could make a heart shaped like the equation r equals 1 plus cosine theta. It would be excellent.
Oh wow, I didn't think about that. Good idea.
So we have the equation r equals 1 plus cosine theta, and we're finding the integral from 0 to pi, and then we multiply the radius by itself, making it squared, and we get an answer of 4.712 inches squared.
Wait, but don't you need to add 1/2? Oh wait, because there are 2 sections, therefore it would be multiplied by 2, and it would cancel out. Therefore, it would still be 4.712.
You know, I'm pretty impressed. You're not as good as me, obviously. No one can be better than me, but you're really improving. You know, do you want to go get some ice cream right now?
I need to study, George.
We have time! We're getting ice cream! Let's go! Raymond, open the door for me right now, and make sure you open it 90 degrees, and cause I'm a big guy. Come on, yeah?
George, we all know there's not enough space for you.
What are you trying to say? You know what? I'm gonna prove you wrong. I'm gonna calculate the amount of volume it takes to open this door by revolving it around the y-axis and using integrals.
Perhaps the Shell's method will work.
Maybe it will. Assume that the height of the door is modeled by y equals root x plus 0.5 and that it's 0.75 meters long.
So the integral will be from 0 to 0.75 meters, and inside the integral, we would multiply the circumference, which is 2 pi x, times the height of the door, which is modeled by the function, which is equal to 2.108 meters cubed.
Wrong, wrong, wrong. You can only open the door 90 degrees, therefore you have to divide it by 1/4, which will give us an answer that is 0.527 meters cubed. So, Raymond, what type of flavors are you into?
I don't know, there's a lot of flavors I like. I like chocolate, strawberry, banana, vanilla.
Kid, be careful, dude. That is a lot of flavors. You don't want to end up like me.
Okay, well, I'll just get 1 scoop of chocolate, right? And then I'll get 2 scoops of strawberry, then 4 scoops of banana.
That's dangerous. You're cooking up an infinite series right here. And that means you'll end up with infinite amount of ice cream.
Isn't that a good thing?
No, because then you'll never finish their ice cream. Let me explain to you what will happen. If your scoops keep getting bigger, it could be modeled, for example, by a geometric series 2 to the n, and this would diverge and give you an answer of infinity, and that's because the common ratio is bigger than 1. If you had a common ratio that was less than 1, let's say 1/2, that could give you, in this case, the answer of 2, and that converges.
2 scoops? That's barely anything!
Kid, trust me, that is enough. That's all you need. You know what? Let's just hit the road, and we'll decide there.
Two hours later.
Oh, that hits the spot.
Where's George?
Oh, he went home, I think.
Oh. How was your private math session?
Oh, it was so helpful. I learned so many things today. I learned volumes of revolution,
integrals, related rates, polar area, and infinite series, all while eating delicious ice cream.
Wait, you're telling me that you were eating ice cream?
I mean, what ice cream?
Can I have some?
Sure thing, Dad.
No!